Welcome back all my dear students of Primary 6, a new session in Unit 1, Lesson 1, Mass and Weight. Last time we stopped at the meaning of mass, and we also talked about the measuring units and the measuring devices which can be used to measure the mass of any object. For the meaning of mass, we said that it is the amount of matter in an object. The amount of matter in an object. And if you remember, I said that if we have two objects, the object that has greater amount of matter will have a greater mass. And we talked about the devices or the tools that can be used to measure the mass of any object. You remember? Can you tell me what are the four devices that we mentioned last time? We mentioned the balance scale, the one-arm digital scale, the one-arm scale with pointer, and finally we stopped at the sensitive two-arm scale. So I said I have four devices. These four devices can be used to measure the mass of any object. I started with balance scale. You remember? Tell me. One-arm scale with pointer, sensitive two-arm scale, and finally we mentioned the digital scale. After that, we talked about the units that we use to measure the mass. I told you if you go to the supermarket and you bought some fruits or vegetables, the amount of fruits or vegetables that you bought, before you pay the money, you should go and check their mass. And the device which is commonly used in most of the supermarkets or the hypermarkets is a digital scale. The digital scale, as I said before, it has a digital screen, and the amount of matter will be written on this digital screen in the form of digits. So, I said I bought some fruits or vegetables. The amount of fruits and vegetables you bought will be measured in kilograms. So, kilograms or kilogram is the measuring unit for large masses. Do you remember? 1 kilogram is nearly equal to the mass of 1 liter of distilled water. The mass of 1 kilogram is nearly equal to the mass of 1 liter of distilled water. And we also talked about the small masses like gold and silver. The measuring unit for the small masses like gold and silver is gram. And the mass of 1 gram is nearly equal to the mass of 1 paper clip. Today I'll start with the properties of mass. Let me ask you, when you come to the school, you bring your water bottle. At the beginning of the day, the water bottle is filled to its end. It will be heavy because the amount of matter in the water bottle is a greater amount. So the bottle will be heavy and the amount of water at the beginning of the day will be great amount. By the end of the day, you may drink all the amount of water. The bottle of water may be empty, so its mass will decrease. So, as you put more water in the water bottle at the beginning of the day, the bottle will be completely filled with water. Its mass will be a greater mass. By the end of the day, as you drink the water or as the amount of water begins to finish, the mass of the water bottle will decrease. So, let me give you another example. For your pencil case, when you put all your supplies in the pencil case, it will be heavy. If you take them out, the mass of the pencil case will decrease. So, the first property of mass that we have talked about. The mass of an object increases by increasing the amount of matter in it. But let's back to the first one. We know that matter has 3 states: solid state, liquid state, and gaseous state. All the states of matter have mass. All matter have a mass, whatever their physical states. So, the first property in mass is all matter have a mass, whatever their physical states. I mean solids, liquids, and gases have mass. And as I mentioned before, the mass of an object increases by increasing the amount of matter in it. Same like your pencil case, when you put all your supplies, it will be heavy. It will have a greater mass. It will have a greater amount of matter. As you take them out, it will be light. The mass will decrease. So, as we increase the amount of matter in an object, its mass will increase and vice versa. When I say vice versa, I mean take them out, the pencil case will be light, the mass will decrease. And finally, to a very important, or the most important point here. Why do we say that it is the most important point? In most of the science exams, in this lesson, you may be asked about, I can give you the mass of an object on the surface of the Earth. And the question will be, what is the mass of the same object in any other place, on the moon's surface, or on the surface of any other planet? Let me repeat it. I'm saying that I can give you the mass of an object on the surface of the Earth. For example, the mass of your body on the Earth's surface is 40 kilograms. And the question is, the mass of your body on the moon's surface will be 30 kilograms, more than 30, or less than 30? This is the question. Try to think about the answer. When I say more than 30, the mass will increase, or doesn't it change, or the mass will decrease? The right answer for this question, which comes usually in the science exams, is the mass of an object. The mass of an object doesn't change by changing place. The mass of an object is a fixed value, stable value. Doesn't it change by changing place? The mass of an object is a fixed value or stable value, which means that it doesn't change by changing place. Wherever you go, your mass is not changing. Your mass on the surface of the Earth is equal to the mass of your body on the moon or any other planet. So we should know that the mass of an object is not changed by changing place. So we call it as fixed value or stable value because it doesn't change by changing place. So the third property here, and the most important one, because we usually mention it in the science exam, is that the mass of an object is a fixed value that doesn't change by changing place. Let me ask you, or let's make sure if you understood this part. I have a very simple problem, an easy problem. Let's read it. An object's mass on the Earth's surface equals 30 kilograms. Calculate the mass on the moon's surface. An object's mass on the surface of the Earth equals 30 kilograms. Calculate its mass on the surface of the moon. Before we answer, you should ask yourself, I have the mass on the Earth, and I have to calculate the mass on the moon's surface, or the mass on the surface of the moon. Back to the last property that we have explained. We said that the mass of an object doesn't change by changing place. So the mass on the surface of the Earth will be equal to the mass on the moon's surface. On the Earth's surface is 30 kilograms. On the moon's surface, it doesn't change, so it will be 30 kilograms. And this is the right answer for my question. The mass of an object, or the mass of the object on the Earth's surface, is equal to its mass on the moon's surface equals 30 kilograms because the mass is a fixed value or stable value, doesn't change by changing place. And now, my dear students, I came to the end of the session today. But before we end our session, I have a question. Test yourself. Try to answer this question. I'll just give you the oral exams, the oral answers for this question. Write the scientific term. Write the scientific term. Number one, the amount of matter in an object. The amount of matter in an object. The right answer for this question will be the amount of matter in an object is. I can hear some of your answers. So, the amount of matter in an object is called mass. Now, we will move to number two. The measuring unit of mass, which equals the mass of 1 liter. 1 liter of distilled water the measuring unit of mass, which equals 1 liter of distilled water. When we say measuring unit of mass, if we stop here, it may be gram or kilogram. If we stop here, if I say the measuring unit of mass, I can say gram or kilogram. You should read the question to its end. You should read the question, especially these questions should be, you should read it well to know the right answer. The measuring unit of mass, it may be, as I said before, gram or kilogram, but this unit equals the mass of 1 liter of distilled water. Because we said this unit is equal to the mass of 1 liter of distilled water, it will be kilogram. It will be kilogram. For number 3, a device. Here we talk about a measuring device, not a tool. We don't talk about a measuring tool. Sorry, we don't talk about a measuring unit. I'm asking you about a tool or device. Measuring tool or measuring device. The device for measuring the mass of objects. You know the answer? I think it is a very easy question. A device used to measure the mass of objects. We have 4 devices. Balance scale, tell me. Digital scale or one-arm digital scale, one-arm scale with pointer, and finally we have sensitive 2-arm scale. So how many devices can be used for mass? We have 4 devices. You can mention any one of them. We can say balance scale, one-arm scale with pointer, one-arm digital scale, and finally we can mention the sensitive 2-arm scale, which is used for the small objects. And finally, to the measuring unit of mass. Measuring unit of mass, which equals the mass of 1 paper clip. When I say 1 paper clip, I mean the measuring unit which is used for the small objects, like gold and silver. What is the measuring unit for the small masses, which is equal to the mass of 1 paper clip? The answer will be gram. So try to write this question and answer it. And for any question, you can ask your class teacher. Now to the end of our session. Thank you so much for watching. See you later in other videos.